In this video, you're going to learn how to take the nth roots of a complex number, and we're going to go through 4 examples together. I'm going to try to make this a lot simpler for you and show you a way to approach these problems. So let's dive into the first example. We're going to find the square roots of 4 cosine 240 plus I sine 240. Now this is what's called the trigonometric form of a complex number. This is your R, or your modulus, and then this is your angle here, sometimes referred to as the argument. But when it's in this form, z equals r cosine theta plus I sine theta, if you want to take the nth root, you've got to take the nth root of the r value, and then this is going to show us how to find the angle. And I'm going to show you a little shortcut in regards to finding that angle in just a moment. But the key thing here is that when you take the square root, you're going to get 2 answers. If you take the cube root, you're going to get 3 answers. Fourth root, you're going to get 4 answers. So diving into this first example now, we're going to take the square root. Okay, that's the nth root. Since we're taking the square root, that's 2. So the square root of 4 is going to be 2. And now what I'm going to do is I'm going to take this angle and I'm going to divide it by 2. If it was a cube root, I divide it by 3. If it was the fourth root, I divide it by 4. Now what I'm doing here is I'm going to think of this as 2 separate fractions. So it's going to be the angle divided by the root, the square root, which is 2. So this is going to be cosine of 240 divided by 2, which is 120, plus I sine 120. That's going to be our first square root. Now the second square root, what we do is we take, in this case, 360 degrees. If you're in radians, you're going to take 2 pi, and you're going to divide it by 2. If we were taking the cube root, we divide it by 3. The fourth root, we're going to divide it by 4. And we're going to add that to get the next angle. So in this case, 360 divided by 2 is 180. So I'm going to add 180 to this angle here, and that's going to give us cosine of 300 degrees plus I sine 300 degrees. Now this is still in the trigonometric form. A lot of times it'll ask for it in the standard form. That's the a plus bi form of a complex number. And the way that you would do that is, let's figure out on our unit circle, what's the cosine of 120? Now, I'm sure you're probably familiar with the unit circle by now. The cosine of 120, that's going to be -1/2. And the sine of 120 is going to be square root 3 over 2. Okay, so now when I distribute, 2 times -1/2 is going to give us -1. And 2 times square root 3 over 2 is just going to give us square root of 3i. So that's in the a plus bi form. So that's one of our square roots of the complex number. The second one here, the cosine of 300, that's going to be also 1/2. And the sine of 300, this is going to be negative square root 3 over 2. And when I distribute the 2 now, 2 times 1/2 is going to give us 1. And 2 times negative root 3 over 2 is going to give us negative square root of 3 times I. So those are our 2 square roots of this complex number. Now you could check it by squaring this, multiplying it by itself, and you'll get back the original number, the original complex number. Same thing here. One thing that's interesting about these roots, or nth roots of complex numbers, is that they're equally spaced around the circle, the unit circle. So in this case, if we were to think of a circle with radius 2, let's just do a circle radius 2, and an angle of 120 degrees would put us right about here, and 300 degrees is going to put us right around here. So basically, if we were to plot these complex numbers, they're symmetric around this circle. So if we had 3 of them, they would be, again, evenly spaced or equally spaced. Fourth root, same thing. So we're going to see that pattern. But I just want to point out one thing before we do the next example. See, in this formula, I think sometimes students get a little bit confused because you can obviously see there's a lot going on here. But see, if you're taking the square root, the k value is going to go 0 and 1. It always goes to 1 less than the root that you're dealing with. If it was a cube root, it would be 0, 1, 2. If it was a fourth root, 0, 1, 2, 3. It's always 1 less. When you put in 0 for that first root, 360 times 0 is 0. So you just get the angle divided by n. In this case, n was 2. That's how I got this first angle of 120. Then to find the next angle, what I'm doing is I'm adding, okay, theta divided by n, which was in this case 120, plus 360 times 1 divided by 2, which was 180, and that's how I got the next angle. Let's take a look at another example. I think you'll start to get a feel for the pattern. For the second example, we're going to find the cube roots of negative 4 square root of 2 plus 4 square root of 2i. So in order to do this, we want to put this complex number in the trigonometric form, which means we need to find the r value and the angle. So what I sometimes like to do is I like to graph this, just plot it, just so I can get a feel for what this looks like. So this is our real number line. This is our imaginary direction. Okay, so if I go left 4 root 2 and up 4 root 2, that's going to put me right there. Okay, and that's the plotting the complex number in the complex plane. But to find the r value, we can use this formula, the square root of a squared plus b squared, and you take the square root, right? So in this case, this is going to be r equals the square root of negative 4 root 2 squared plus positive 4 root 2 squared. That's our a and our b. So if we do this, we're going to get 32 plus 32. Now, see, negative 4 squared is 16. Square root of 2 squared is 2. 16 times 2 is 32. Same thing here. That's going to be 32. That's 64. Square root of 64 is equal to 8. And if we want to find our angle, we can use this formula, the tangent inverse of b over a. Okay, so that's going to come out to tangent inverse of b, which is 4 root 2, divided by negative 4 root 2. Okay, now you can see that this is negative 1. Okay, so I'll just cross this off and say negative 1. Tangent of what angle equals negative 1? Well, you know from learning about the inverse trig functions, tangent is restricted from negative pi over 2 to positive pi over 2, right? So negative pi over 2 to positive pi over 2. And that would actually give us an angle here of negative 45 or negative pi over 4. But you can see when I plotted that complex number, I'm over here in the second quadrant, okay, over here. So I'm going to have to add 180, or I'm going to have to add pi radians. So negative pi over 4 plus pi, that's actually an angle of 3 pi over 4. Now you can do this in degrees if you want, say 135 degrees, but let's do this problem in radians just to get a feel for how to work with the formula in this form in radians. Okay, so now if we write our complex number in trigonometric form, it's going to be 8. And then I'll even show you another shortcut too. Some teachers will use this kind of like condensed way of writing it. They say cis, 8 cis, 3 pi over 4. This just means cosine I sine. Okay, so it's just a kind of like a compact way of writing it. Now we want to take the cube root, which means we're going to get 3 answers, right? So the way we do this is we take the cube root of r, which in this case is going to be the cube root of 8, which is going to be 2. And then I'm going to use the abbreviation cis. That's just cosine I sine, okay, cosine theta I sine theta. But what I have to do is I have to take the angle divided by 3, since we're taking the cube root. So 3 pi over 4 divided by 3 is going to be pi over 4. Okay, so that's going to be our first answer. Now, how do we get the next one? Well, the next one, it's also going to be an r value of 2, cosine theta plus I sine theta. To get the next angle, we're going to add 2 pi divided by 3. Okay, so 2 pi divided by 3. Now, if we add pi over 4 plus 2 pi over 3, we have to get a common denominator. So let's do that. So adding 2 pi over 3 to pi over 4, let's see, multiply this by 4 over 4, that's 8 pi over 12. Multiply this by 3 over 3, that's 3 pi over 12. So that gives us 11 pi over 12. And then if we do it one more time to find the third complex root here, we're going to have to add another 8 pi over 12, which is 2 pi over 3, and that's going to give us 19 pi over 12. So the key here is, see what I'm doing is I'm splitting this up. I'm saying theta divided by n. That was our original angle, 3 pi over 4 divided by 3, which gives us pi over 4. And the reason that's just theta divided by n is because we start off with k equals 0. 0 times anything is 0, so that's how you just have theta divided by n. Then we're adding this 2 pi over k divided by n. When k is 1, that's going to be 2 pi divided by 3. When k is 2, that's going to be 4 pi over 3. When k is, etc. And you go all the way up to 1 less than the root that you're taking. So if it's the cube root, you go up to k equals 2. But the way this works is you keep adding 2 pi over 3, 2 pi over 3 like that each time. So that's what I did here is I just added 2 pi over 3, added another 2 pi over 3. What's interesting about these complex roots is they're equally spaced or evenly spaced, evenly distributed around a circle. And you'll see that. I'm going to graph these in just a moment. Let's do it right now, actually. So you have an R value of 2. That's like the radius, basically. The modulus is the distance from the origin in your complex plane. And then pi over 4 is your angle. So pi over 4 would put you, let's just say this is a circle of radius 2. Pi over 4 would put you right here. And 11 pi over 12, that's just a little bit less than 12 pi over 12, which is pi. So that's going to be somewhere right about here. And then if we graph 19 pi over 12, that's a little bit more than 18 pi over 12, which is 3 pi over 2. So just a little bit past 3 pi over 2, be right there. So you can see they're like equally spaced apart. It's like they're 2 pi over 3 apart from one another. So it's kind of a neat pattern there. But now these are in the trigonometric form, okay? If we want to go to the standard form, the a plus bi form, what you would do is, again, remember this 2 cis pi over 4 is really like this. It's 2 cosine pi over 4 plus I sine pi over 4. Pi over 4 we know is square root 2 over 2, or cosine pi over 4 is square root 2 over 2, and sine of pi over 4 is also square root 2 over 2. And if we multiply by 2, that's going to cancel out these denominators here, and we're just going to be left with square root of 2 plus square root of 2i. So that's an exact value for the complex number in standard form, a plus bi form. 11 pi over 12 and 19 pi over 12, we're not familiar with those angles on the unit circle, so we're going to have to do some calculations here. So this is going to be, let's see what this comes out to. So it's going to be 2, the cosine of 11 pi over 12. Make sure your calculator is in radians here. I'm using it TI-84. If you want to check that out, I'll put a link. So let's see, this is 2 times cosine of, well, actually here, let's do it in part. Let's do it all together. So I'm going to do 2 times the cosine of pi over 4 and 2 sine pi over 4. So 2 cosine pi, I'm using the pi key, and 2 sine, oh, that was the last problem. Let's do 11 pi over 12. 2 cosine 11 pi over 12 and 2 sine 11 pi over 12. Okay, so this is coming out, if you're checking at home, it's negative 1.93 plus 0.52i. Okay, that's our second complex root. And then the third one, we're going to do 2 cosine of 19 pi divided by 12 and 2 sine 19 pi divided by 12. Okay, so this is coming out to 0.52 minus 1.93i. So these are your 3 roots in the standard form. These are your 3 roots in the trigonometric form. Of course, I even condensed it a little bit further by saying the cis instead of the cosine theta plus I sine theta. And those are your solutions. Let's take a look at another example. For example number 3, if you're getting the hang of this, see if you can do this one on your own. But we're going to find the 4th roots of negative 16i. So because it's the 4th root, we're going to be getting 4 solutions. And this one's kind of interesting because it's kind of a simple one, right? Negative 16i. See, this is our real number line. So we're going 0 in the real direction, negative 16 in the imaginary. So this is like a and this is like bi. So we're going down negative 16 right here. So that's the location of our point in the complex plane. So this makes it easy because the r value, that's the distance here from this origin, that's a distance of 16. So we know r is 16. And we know that our angle here is either negative pi over 2, or we go this way, make it a positive angle, 3 pi over 2. So let's just write this as 16 cosine 3 pi over 2 plus I sine 3 pi over 2. So we didn't have to do a lot of calculations using this r formula and this theta formula. You can, the only thing that's you have to be a little bit careful of, if you're doing the tangent inverse of b over a, you're going to get undefined because the a value is 0. And tangent, you do the tangent inverse, it's undefined here at negative pi over 2 or at positive pi over 2. So that's why it's always helpful to graph the number in the complex plane so you can see that, okay, this is my location, it's down here, okay. So now we've got our the complex number in trigonometric form. We want to find the 4th roots, so we're going to take the 4th root of r, the 4th root of 16 is going to be 2. And we're going to take our angle, 3 pi over 2, we're going to divide it by 4 since we're taking the 4th root. So that's going to give us 3 pi over 8. So this is 2 cosine 3 pi over 8 plus I sine 3 pi over 8. Now, that's just the first one. The second one, it's going to be 2 cosine. To find the second angle, we're going to have to add 2 pi divided by 4, since we're taking the fourth root. 2 pi over 4 is the same thing, so I'm just going to put plus 2 pi over 4. That's the same thing as 4 pi over 8. So to add 4 pi over 8, our next angle would be 7 pi over 8. Okay, I sine 7 pi over 8. The next one, we're going to add 4 pi over 8, which is 2 pi over 4, or pi over 2. Okay, so we're going to add that again, so that's going to be cosine of 11 pi over 8 plus I sine 11 pi over 8. And we're going to do it one more time. That's going to be cosine of 15 pi over 8 plus I sine 15 pi over 8. Now these are our answers right here in trigonometric form. Sometimes they'll just say leave it at that. But if you want to go into standard form, you're going to want to distribute this 2. So you're going to say 2 cosine 3 pi over 8 plus 2 I sine 3 pi over 8. You'll have to do that on your calculator since these aren't ones that we know on the unit circle. And you put it in that standard form, this a plus bi form, for each of the roots here. Now, just if we wanted to see this graphically, imagine that this is a circle with radius 2. And our angle, 3 pi over 8, that's a little bit less than 4 pi over 8, which is pi over 2. That's going to be somewhere up here. Okay. And the next one's 7 pi over 8. That's a little bit less than 8 pi over 8, which is pi. And then we have 11 pi over 8, which is a little bit less than 12 pi over 8, which is 3 pi over 2. So that's going to put you right here. And then 15 pi over 8, that's a little bit less than 16 pi over 8, which is 2 pi, which is right here. Now, my drawing's not perfect, but see how they're equally spaced, like they're 90 degrees apart? And you can see that comes from the formula here, 2 pi divided by 4. We kept adding pi over 2, which is 90. So that's how they're equally spaced, those complex numbers in the complex plane. And that's kind of a neat feature there. So let's take a look at one last example where you're using the roots of a complex number to solve an equation. So let's take a look at that next. To do this last example, I just wanted to let you know that you can now join as a channel member to the Mario's Math Tutoring YouTube channel. And if you're preparing for like a midterm or a final exam in pre-calculus, for example, which this topic is usually covered in, I've got some midterm and final exam reviews on the additional videos level. So if you join at that additional videos level, you can get access to over 120 other videos on my membership there. And a couple of those videos will be helpful to you preparing for like a pre-calc midterm or final. So check that out if you're interested. But to solve this now, it's just like solving an algebra equation, right? You're trying to get that variable by itself. So I'm just going to add I to both sides. So that gives me x squared is equal to I. But now I is really like 0 plus 1i, if we want to write this in the a plus bi form of a complex number. We want to take the square root, okay, to get x by itself. But to take the square root of a complex number, it's easier if we put it into the trigonometric form. So let's do that first. So what is 0 plus 1i? Well, I like to graph it just to visualize. This is the real direction. This is the imaginary direction. So I'm going 0 on the real direction here, up 1, okay, in the imaginary direction. So that's the location of our point in the complex plane. So this makes it very easy to find the r value. This r value is just going to be 1. That's the distance from the origin. And the angle you can see is just going to be pi over 2, or 90 degrees. So let's just do this one in radians, pi over 2 plus I sine pi over 2. So that's our r value and that's our angle. Okay, but now what we're going to do to find x is we have to take the square root of this complex number in trigonometric form. So we take the square root of r, so the square root of 1 is going to be 1. We're going to take the angle, which is pi over 2, divided by 2, since we're taking the square root. So pi over 2 divided by 2 is pi over 4. So this is going to be cosine pi over 4 plus I sine pi over 4. These are always going to be the same, right? They match. But to find the next angle, we're going to have to add 2 pi divided by 2, since it's the square root. So we're going to have to add pi to get the next angle. So a pi plus pi over 4 is going to be 5 pi over 4. And these are two roots in the trigonometric form. Now, if we want to find it in the standard form, let's go ahead and do that. Cosine of pi over 4, we know that this is equal to root 2 over 2. And sine of pi over 4 is also root 2 over 2. Cosine of 5 pi over 4 is a negative root 2 over 2, and sine of pi over 4 is also negative root 2 over 2. So now if I multiply by 1, of course 1 times anything is itself. So we're just getting root 2 over 2 plus root 2 over 2i, and we're getting negative root 2 over 2 minus root 2 over 2i. And those are your two complex numbers. Now, if you want to check your work, you could square these and you get back, the original. So great job if you were able to follow these 4 examples. If you want more practice, I'll put a link to another video I did right there talking more about working with complex numbers. I'll see you over in that video.